Hello everyone, myself Dhanraj, and my today's topic is vhdl model and behavioral models. vhdl stands for VHSIC Hardware Description Language. It's a programming language used to describe behavior and structure of electronic circuits like those inside our computer or smartphone. Essentially, VHDL allows engineers to create models of how their digital circuits should work. They can then these models on a computer before building the actual hardware ensure everything functions correctly and efficiently. Think of it as a blueprint of digital devices helping designers plan out and simulate the electronic components connection. Models in VHDL. En- Entity architecture process. This part lists entity. This part lists the input and outputs of module, like a door sign showing how can come in and go out. Architecture. This describes what happens inside the model, like the blueprint of a house showing all the rooms and how they are connected. Process. This part explains the sequence of action that occur when the input changes similar to following steps in a recipe. Key features. VHDL can handle multiple tasks at the same time, which is great for designing complex system connecting parts. You can join different models to create larger and more architect design testing. You can create simulations to test your design before actually building the hardware, catching any errors early on. Uses FPGA and ASIC. FPGA design making custom hardware circuits. ASIC design creating specialized chips for specific tasks. Simulation testing designs virtually to ensure their work. Applications of VHDL module: designing combination and sequential circuits, building microprocessors, memory controllers, and custom logic, simulating digital systems to validate functionality before hardware implementation. So next, what is behavioral model? Behavioral model refers to a mathematical framework used to describe, predict, and understand the behaviors or actions of individuals, groups, or systems in various contexts. The goal of a behavioral model is to explain why the certain behaviors occurs and how they can be influenced or changed. Key types of behavioral model: psychological models, economical models, sociological models, computational and mathematical models, and behavioral health models. So first, psychological models focus on individual behaviors based on psychological theories such as the theory of a planned behavior or operant condition. Economic models based on how individuals or organizations make decisions, often seen in a behavioral economics, which examines how psychological factors influence economic decision making. Sociological models. This look at how social environments and group dynamics affect behavior, such as social learning theory or normative social influence. Computational and mathematical models used in artificial intelligence, machine learning, or system analysis. These models simulate behaviors in a digital environment or population. Behavioral health models focus on the predict health related behaviors such as health psychology or public health intervention, which still provides several key structures for behavioral modeling, including process signals and variables. Understanding these constructs is essential for creating effective and efficient VHDL code accurately represent system behavior. Key aspects of behavioral model: input variable factors that influence behavior, example belief, attitude, past experiences. output, the behavior or action that the result of the input variables. Feedback loops, how behavior can influence future action or outcomes, forming a cycle. Behavioral models are applied in the various fields including psychology, economics, marketing, healthcare, and even machine learning to enhance the understanding and inform decision making. So next, processes in VHDL. A process is a in VHDL is a concurrent statement that allows sequential execution of a code within it. It begins with the process keyword and ends with end process, and the allowing the reactive designs and respond to changes the input signals dynamically. Sensitivity list. The sensitivity list specifies the signal and the trigger the execution of the process. Whenever the signal is the least changes, the process is executed. If the sensitivity list is omitted, the process will execute indefinitely unless the controlled by an internal wait statement. Sequential statement. Inside a process, statements are executed sequentially, unlike outside the process where all the statements are concurrent. Combinational logic using processes. A process can model combination logic by ensuring all signals assigned inside the part of the sensitivity list. Next, variable versus signal. In VHDL, both variable and signals are used for store manipulate data, but they have distinct difference in terms of behavior, scope and usage. Understanding this difference is crucial for designing digitals effectively. Key difference between variable and signals. Next, VHDL supports the both sequential and concurrent statements. Sequentially, statements are executed in a specific order within the process, while concurrent statements are executed simultaneously, allowing for parallel operation in the design. VHDL offers a variety of data types, including bit, integer, and std logic. Each data type serves different purpose and aspects how data is manipulated and stored in the design, impacting overall performance. A test bench is a crucial component in VHDL that allows designer to verify the functionality of their models. It stimulates the environment and applies various test cases to ensure the design based on aspects. Common challenges. Designing with the VHDL can represent challenges and synthesis issue, timing constraints, and debugging difficulties. Understanding these challenges helps designer develop more efficient and reliable VHDL code. Next, best practices for VHDL. Properly to enhance the effectiveness in the VHDL indent code and align keywords for the better readability. Explain the purpose of processes, signals, and logic. Use comments on to clarify non-obvious code. Break down the large designs into the smaller reusable models to improve readability and reusability. Use self-explanatory names for signals, entities, and for next advantages of behavioral model. Psychology and human behavior. Models are classical conditioning and Skinner's operant condition help in the education and training programs. Behavior therapy used in treating the FUOPS addiction and their psychological condition by modifying behavioral patterns. Marketing and consumer behavior, economics and finance, and education and healthcare, and mainly in artificial intelligence and machine learning, software and system design. Conclusion. In conclusion, understanding behavioral models in VHDL is essential for effective digital design. By mastering key concepts and best practices, designers can create robust and efficient systems that meet modern demands.